Hi everyone, in this video we're going to learn about the nerve stuff in our body. We talk about your lung, how connected to and how it works, and probably your heart, how it works, or the nerve stuff. Alright, so first, I might probably forgot to mention that, but do you know what heart is made of? You know, if your heart would get tired, you probably just die. Because your heart need to pump your blood to your whole body, just can't even rest for a single second. So it's actually made out of those specific cardiac muscle, which means that they won't even get tired. And when you do, like, for example, uh, like squeezing this stuff, alright? Like squeezing this stuff, right? So your hand, your muscle, your forearm is actually using some power. And then when you keep using those power, those muscle just kind of they actually just borrow later the oxygen so they can work right now because the oxygen level is not enough, right? So they build up some acid in there. So when you do a lot of them, your hand will get tired and sore. Why? Because yeah, just acid build up. But if it happened on your heart, you probably just die. Yeah, because you need rest. So you need to build a muscle that it can rest until you die. Yeah. So treat your heart better, rest more, and don't eat too much junk food. Yeah. And so we're now first going to talk about lung, the lung, and those stuff like first how we breathe, right? You know how we breathe, and you know how we do gas exchange and the structure of lung. But actually, what is controlling it? That's the problem, isn't it? So, I mean is, your brain actually got so many parts. You can actively control your lung breathing. It's because you got a, like, you can active control it. It's your motor area in your cerebrum, not your brain, yeah. And but for the passive breathing, like even you pass out you can breathe. Why? Because it is not what you control like a dolphin. Like for dolphin, they control it with their mind. There is some consciousness move. It's not passive. Yeah. So they actually just can't even fully go asleep. But for us, if I can't go to sleep, you're probably just tired as hell, right? You're tired as hell. So what helps us? So this is the medulla oblongata. It just seems like some random Harry Potter magic words. But actually it's not, it's just a real scientific name for that organ. That's what control those passive movements. When there's a respiratory center which control your breathing. Right? But how to control it is quite easy. You got a chemoreceptor located in your heart. I'll put a picture here. Located in your heart, which is located on your uh, aortic bodies and carotid bodies. Yeah, I just give you a picture there. Else you don't even know what the fuck is that. So those chemoreceptors just detect your blood pH. Blood pH is mean what? It means the level of carbon dioxide inside. When you're just not breathing, it will just keep consuming the air inside your lung. So it will keep building up the carbon dioxide level. But if you don't exhale, so the carbon dioxide level will build up, and because if it react with water, it will form carbonic acid, right? So which means the pH will keep lower. So it will, the chemoreceptor in your aortic and carotid bodies will just send those like statistic stuff or yeah, some info to your medulla oblongata respiratory center. So then it can analyze it to see whether you are doing some movement or stuff or you're just resting. If we are resting here, we just be normal, we breathe normal, right? But if we sleep, because we're not using any muscles, so we basically just breathe more or lesser. I mean, the breath rate and the speed, that's what it decides. So if you are doing some, for example, workouts or you're running, the chemoreceptor will just detect, oh, now the pH levels is low because you're not breathing enough, you're not using the max efficiency to breathe out those carbon dioxide. It keep building up. I mean, it keep building up in your blood, right? So it will just send some nerve impulse to your medulla oblongata, so it will know you need to breathe faster, right? In order to regulate your blood pH. So it will send more nerve impulse to your diaphragm and your intercostal muscle, which we already talked about in previous video. So it will send more nerve impulse to it, so it will contract harder and faster. Yeah, that's exactly how it works. I guess that's it. Yeah. So maybe now we're gonna talk about like yeah, that's because your cerebrum, you got a motor area, right? You actually can control it. Like if you now think about breathe, you actually are actively breathing. You can control breath, you can close it, you can not breathing. Alright? Yeah. So you can control it like so you can actually your cerebrum can override your medulla oblongata if you want. Yeah, probably that's it. So the important part is we're going to talk about the heart. This is kind of like complex. Like, so first, how our heart move. For our heart, it is cardiac muscle, right? So you need some impulse. Like, if your brain keep thinking about it, you'll just overheat your brain. Because every second you need to think. So what you do, you can't just keep sending message to your head, right? You need to move it by itself. So you can see maybe in some videos, those heart you got taken out from your bodies and keep moving. Why? Because even you die and your body dissolve, but only left over your heart. You keep it in a great temperature and keep giving the blood some oxygen. It still work. Yeah. Why? Because it sends nerve impulse to itself. But how? Yeah. So in the vena cava, near the vena cava, it actually got a we can call it pacemaker or sinoatrial node. You can also call it SA node in short. So the SA node will detect whether it's got blood here or not. And got blood here, and you can just it will send the nerve impulse to your left and right atrium. We will just contract, suck it in and contract, and then boom, it contract through the bicuspid or tricuspid valve and to your ventricle. Well, at the same time, you also send a nerve impulse. I mean the pacemaker, the sinoatrial node. It will send a nerve impulse to your bundle of His, which is located in your septum. Yeah, the heart it got a septum. Yeah, in previous video I showed a picture, right? Yeah, it already shows septum because you need to separate left or right to separate the oxygenated blood or deoxygenated blood. So through the septum, through a bundle of his, it will go to the tip of the heart. And yeah, and then the nerve will be like this, going up to your ventricle muscle. And then will, after sending it, it will contract, right? Contract, and it will go up and move again. Because maybe last video I didn't mention, your heart actually got a dorsal side and I remember is it ventral side. Yeah, I guess it is. So dorsal side is mean that the back of your heart. Ventral side is mean the front of your heart. Yeah, that's it. So and also after sending the nerve impulse, right? So you contract, relax, right? And then that's it. Actually, just after you receive blood, that's it. It will auto do all the movement. But haven't you wonder how the heart even gets blood? Because it's cell, right? You need to get blood, you need to get oxygen, right? So right after it get oxygen through your pulmonary artery, pulmonary vein, and then you go to the aorta, right? Aorta. And then there's a like a vessel connect to your heart, which is called the coronary artery. Yeah, you don't need to remember too much of it, but you need to know it. So after you know this, I'm gonna talk about like what's the heart do. I might just put some timing here. When will your heart contract? What's like from 0.1 second to 0.4 second to 0.8 seconds? I just need to remember the stuff like the movement and when it moves. As I remember, there's a like name for those. Like when your heart contracts, it will send nerve impulse, right? We got names. Yeah, you got names. I make sure picture stuff here. You know the names, right? Just type it here. And so for the first one, just send nerve impulse, right? Just like what we talked about. When you contract the atrium and send the blood to your ventricle. That's the first part. The second part is they close the valve, bicuspid, tricuspid, they close. So they form a loop sound, which if you just got some knowledge or you heard enough, you might just know your heart makes sound, which is looped up. Yeah, so the first sound is your tricuspid and bicuspid valve closing. That's the first sound. So after that, they just contract, right? The ventricle contract. Yeah, I forgot to tell you the sinoatrial node, and then you send nerve impulse to your atrioventricular node, which you can call it AV node. And after that, it contract, right? Then they will go up through the semilunar valve. So that's the stuff. Like, I remember it's called diastole. Yeah. So after they stand up, right? They will close, right? So the sound of duck is actually from your semilunar valve. It closes and give a sound. Just remember, when your valve closes, it makes sound, not when your heart pump. It won't make sound. Only your valve close will make sound. Also, when I talk about like those nerve, how it affects our stuff, like how we actually know, how our bodies know, because we can think and let it contract faster. We can't control our heart, right? So it actually all is auto movement. But what you do, like in your heart, not only chemoreceptor, it also got baroreceptor, which is I remember is in aortic arc, or yeah, I guess aortic bodies or aortic. Yeah, it is on the aorta wall and the carotid bodies. Yeah, so they just act not detect pH but the blood pressure. So when they know, oh, you're doing a, for example, you're running, oh, the blood all pump to your leg, oh, there's no blood, the blood pressure drop, the blood haven't come back yet. So what they pump faster, plus your blood pressure kind of dropped, and you need to pump it faster and stronger in order to, like, not for you to pass out. And last is stretch receptor, which locate on your like muscles, limb. It's detect lymph movement. So what they do is send all the nerve into your medulla oblongata in your cardiovascular. Wait. Cardiac. Ah, cardiovascular. Well, whatever. I'll just show it on screen, bro. I forgot it again. Whatever. So in the center, you just process those data, and then they will just put those data, and then you send a nerve impulse back to your heart and tell it to contract much more faster. But also in the case that your sympathetic nerve might just also activate to contract faster, like when you are kind of like cringe or you're embarrassed, you're probably, it might be, yeah, but it usually is. Yeah, I guess that is cardiovascular center. Whatever, just I already showed in screen, right? Yeah, so when your kidney, that's where you produce adrenaline. Yeah, so for the adrenaline, it will just bypass those things which you need to do, like workouts, running, so you can activate to make your heart run faster. But if your adrenaline rise, so it will send some signal through your sympathetic nerve and told your heart to do like a flight or fight movement. Just like yeah, when you see some horror stuff, you just get scared, right? So yeah, that's fight or flight. So um also there's also a nerve called vagus nerve or parasympathetic, god damn, parasympathetic nerve. Alright, yeah, parasympathetic nerve, which also can correspond in vagus nerve. It usually just used when you're like resting. And for sympathetic nerve, it acts as a stimulant. Yeah, so when you're just doing a workout or something, your parasympathetic nerve might just active or something. But for vagus nerve, it's usually just do what it do normally. Yeah, I guess that's it. Oh, well, miss. I guess not. So we're gonna sum up here. To summarize, so now we know how our lung actually just receive those signals to work harder, and where those stuff located, those center. Actually, mainly so many like auto movement is located in your medulla oblongata. And remember it's actually quite easy to remember. Just just think of it as a like magic words. Like in Harry Potter, you got lots of magic words, right? Yeah, so just remember it's important. But also remember when you need to control it by your brain, like breathing, you use your motor area in your cerebral. And the last is your heart. It can move by itself through the pacemaker or a sinoatrial node, or you can call it short in SA node. In exam, remember, like even atrioventricular node, it is long, right? But you need to first write it first, so the examiner will know you're writing the short form, meaning that it is a atrioventricular node. So you need to write the full name first and make a bracket to say it the short form, and then so you can use the short form after that. Yeah, you got me. So yeah, I guess that's it. So study more and don't give up. Bye.